All right, we are recording. This is section 10.3. In your Cornell notes, you should have the section 10.3, and dividing rational expressions is your objective. Okay? It should be pretty easy. I think you can pick it up pretty much right after we do a couple problems. The biggest thing is staying focused and not adding lead to your pencil and really getting your head in the game. Okay. So, does anybody know how to divide a fraction? What's the rule?
You flip the,
We don't flip,
you multiply by the reciprocal.
we multiply by the reciprocal. So when you are dividing, the first thing we do is we reciprocate. Now, I would put these notes on the right on your left side. Okay? First thing we do is reciprocate. I'm flipping the second fraction, and I'm multiplying, as Maxim said. We're multiplying by the reciprocal. So right away, this changes and this reciprocates. Okay? The next thing, what do you think we do? Not yet.
Factor.
We're going to factor. We always factor before we multiply because we want to reduce it. So the top one can be factored to what? What can it be factored to? Go, RJ.
2 parentheses x
2 times the quantity.
2 times the quantity of x minus 3.
Good. All over 5 times 15 over. Go, Jason.
X plus 3 and x times the quantity of x minus 3.
Good. Okay. And now I'm having, I can cross cancel my x minus 3. Huh? Oh yeah, the next step is to notice my expression that that I'm dividing. It works downward. There's don't add equal signs. Okay? And now we're going to reduce by cross canceling. So I get rid of the x minus 3. I can take a 5 and I'm left with 1 and 3. And so we're left with 2 times 3 is 6 over x plus 3. So when we reduce, we're cross canceling. Okay, questions? All right, let's move on. Pretty easy. Okay, so now we're going to try another one. I want you to pause the recording. I want you to factor I want you to multiply by the reciprocate. We factor, and then we cross cancel. Pause the recording and try this one on your own. Okay, let's try it. How would I like to kind of factor and reciprocate at the same time. So how would I factor the first numerator? How about Miriam?
The first one is 4x times quantity of x minus 5.
Good. All over 3x. Now the second one I'm multiplying, and my 6x plus 30 goes right here. But how would I factor that? How do I factor that? Go, Turner.
3 times the quantity.
No, bigger. 6
That's the quantity of
x plus. Good. And then on top, I have my x squared minus 25 becomes what on my new denominator? Riley?
X minus 5 times the quantity of x plus 5.
Okay. So I reciprocated. We start doing a lot of these. It's a lot of extra work, but just double check yourself that this is here and that this is now in the numerator. Okay, what can I cross cancel? Dion?
x plus 5.
X plus 5 and x plus 5. What else?
X minus 5.
X minus 5 and x minus 5. Anything else, Hugo?
Would 63.
A 3 and I'm left with 1 and I'm left with a 2. Anything else, Hugo?
No.
Yep. Adam?
Both the x's in the first row.
I can take an x out here and an x out here. So we're left with in the numerator 4 times 2, which multiplies to 8, and we're left with 1 in the denominator. So our solution is 8. Questions? Okay, let's go on to the next one. Do I have to write over? Okay, let's try the next one. This involves some lead coefficient factoring. Pause the recording and try number 2. Back to the recording. So on the first one, we're going to have to factor, let's multiply by the reciprocal, and then we're going to factor the first one, which what multiplies to 6, multiply by 2, and adds to 7. Go, Greta.
6 and 1.
Good, and so I get x squared. I'm going to just go right to my x plus 1 times x plus 6, but remember we multiplied by 2. I have to divide by 2, so we get, this is now going to become 2x plus 1 times x plus 3. So 2x plus 1 times x plus 3. The denominator, Greta,
Yeah?
what is that factor to?
That's going to be 5 times the quantity of 3 plus x.
Or x plus 3. Okay, 3 plus x, yeah, you're right. 3 plus x, which really means the same thing as x plus 3, times 10x all over. Now I've got to multiply what multiplies to negative 2 and adds to negative 1. Let's go, Jean. Oh. Okay, so it's x plus 1 times x minus 2. Hugo, what do I do next? I did the... I multiplied by 2. So now I have to divide it by 2. And then I end up with 2x. 2x. Look. This happens when we have a lead coefficient. Maybe you were out for that. Lead 2x plus 1 times the quantity of x. This reduces minus 1. Right? Okay, what can be cross-canceled? Gideon?
2x plus 1.
I can take a 2x plus 1. What else, Alice?
You can
Oh.
take the 5x, or the 5 and the 10x.
No, I can't take an x. I can take a
5.
factor of 5, and I'm left with 1. And here I'm left with
2x.
2, but I'm left with also that x. Okay, anything else I can get rid of? Emerson?
I think the 2 x's.
What 2 x's?
X in the parentheses and then x in the...
You can't take a piece of a parenthesis. You cannot take a piece of a binomial. Finnegan?
The x plus 3 and 3 plus x.
Yes, they're the same thing. They're just in different order. They're exactly the same. So in my numerator, I'm left with a 2x, and in the denominator, I'm left with x minus 1. Questions? Okay. So now we're moving on. Do you get the idea? We're just factoring, and then we cross-cancel. I'd like to do this last problem. Okay, let's look at this one. First of all, when I have a whole parenthesis like that, the first one is a y plus 1 to the 4th over y squared. When I multiply, what's going to be my new numerator? Sam?
Y over y plus 1.
No. What's going to be my new numerator?
Oh, y.
No? Yep.
Y to the 6th power.
Y to the 6th power over
Y to the 6th power.
No.
Then y plus 1.
Y plus 1 to the 6th power. So this becomes the denominator, and this becomes the numerator, and they're both to the 6th power. Now, when I get rid of, I have 4 y plus 1s up here and 6 down here. I don't need to multiply them out. I can get rid of 4, and I can take 4, and I'm left with y plus 1 to the 2nd power. We can take 2 y's out here, and I'm left with the number 1. And then I'm left with y to the 4th. So in my numerator, I'm left with y to the 4th over y plus 1 squared. And that is my final answer. I may not cross-cancel the y's. Question. Okay, let's talk about domain. Now, this time, because we're dividing, we have multiple denominators. No, not that one, sorry. We have multiple denominators. Okay, it says divide. Remember, we factor. We find the domain, determine the domain. And then we reduce by cross-canceling. Okay? Now, the first one, I have x minus 2 over 3. There's no denominator there. But this one, I have to account for 3 different denominators. This one, and eventually this is going to become a denominator. So when I'm looking for domain, I have to look into all 3 of those. Does that make sense? Because all 3 of those will be a denominator. And the rule is thou shalt not divide by a 0. I can't have a 0 in the denominator. So I have 3 potential denominators. This one, and this one. Does that make sense? So I'm going to factor it. Let's factor it first. What does the numerator factor to? Yes.
X plus 2 times the quantity of x minus 2.
X plus 2 times the quantity of x minus 2. Okay? Well, they multiplied by the reciprocal. Oh, I erased it. Okay. Okay, I'm going to first factor that, and so then I have a times x plus 2 times x minus 2. So for my domain all over x cubed, I have to deal with that x cubed. Are you with me? We know that it's going to say x is such that x is an element of the reals, comma, and x cannot equal what? For right here. 0, because 0 cubed. If you don't know, set it equal to 0. What time? Okay, for now, don't worry about it. But, because the only thing that could fit in there, so it would be 0 for that. And then I'm multiplying by the reciprocal, right? X minus 2, there's another denominator. Now I have that x cubed, and over here I have x plus 2 times x minus 2. So what would give me a 0 here? Negative 2. So we said a 0 already. We said a negative 2. And what else? What would give me a 0 here? A positive 2. Does everybody understand how I find that domain? Now, it says divide and state the domain. We've stated the domain. It's right here. Okay? Now it's time to divide it or cross-cancel. I can get rid of this, and I'm left with x cubed over 3 times x plus 2. Okay? Is everybody understanding how to find the domain? Yes. Yes.
Wait, I don't get it. So when you flipped it to get x plus 2 and x minus 2 over x cubed, why did you flip it again?
He didn't flip it though.
I didn't flip it, I just factored from here to here.
Oh.
Okay, I only reciprocated once. Yes, Amani.
I don't understand this. I don't understand like how to find the domain for this one.
How to find what?
The domain for this one.
Okay, so what my big point is when you're dividing, you have to think about the denominators when you start and then after you reciprocate, right? Eventually, this, we're going to multiply by the reciprocal, and we see this in the denominator. There's 3 denominators that we got to. There's nothing that happens for this. But what is the only thing that would give you a 0 here? What would x have to be, Amani? A 0. 0 cubed is a 0. So that's my first one. What would give me a 0 right here? What plus 2 equals 0? Good, that's right here. What would give me a 0 right here? Positive 2, that's right here. So we always say x is an element of the reals. X is such that x is an element of the reals because we did that whole big chart yesterday and talked about that any number in the real number system except for 0, -2, and 2 because at one point that can give you a 0 in the denominator. And rule for domain is thou shalt not divide by 0 with fractions. Is everybody clear on that? Yeah.
Does it, when you find the domain, does it always have to be on a separate line from when you wrote the x stuff?
Well, it's a separate answer. Let's look at how they did it. Maybe they did it a little cleaner.
No.
Okay, I mean it's kind of a separate answer. So I likely would not write it all. Does that make sense?
Yeah, I mean it says x and then the colon and that, and then you put it on another line.
No, I don't need it to be on another line. I just put a comma. Okay, like in this one, hold on, let me go. I want you to look at yesterday's lesson, which we didn't have time to go over it. Oh my God. What?
I think I see Kai on the side.
Stop, I'm recording. Not funny. Okay. Shh. So look at this one. Okay, again, it's saying multiply and state the domain for x. It's a 2-part problem. Now this time, the only ones we're going to look for domains is the only denominators that I have to worry about becoming 0 is here and here. So I factor those, x plus 2 times x minus 2, all over x squared, times 2x, this is yesterday's lesson, this is x plus 4, this is x minus 4. So, Amani, what do I say every time? X is such that x is an element of the reals. I only did the second line, Turner, because there's no more room to write, comma, and x cannot equal what? What here? What would give me a 0 right there? 0, a -4, and here, a +4. Okay? Close the braces. Now I'm ready to also finish multiplying it, but before I do that, I'm going to reduce it. I can take an x out there, I'm left with an x. That's all I can get rid of, right? So I'm left with 2 times x plus 2 times x minus 2, and this is all x plus 4, x times the quantity of x minus 4. Okay? Here's the domain, and here's the simplified fraction. Is everybody clear on how to find the domain now? Okay? That's going to be a question that's going to keep coming up. Whoa, what happened here? What did I do wrong? Oh, yeah. Okay, stop. Stop, Mamasaki. Shh, I did it wrong because it wasn't a difference of squares. I factored it wrong. So, no wonder why I couldn't. I was like, it doesn't seem like they give me that. It should have been x times x minus 4 over x squared times 2x. Boy, just, and this is x plus 4 times x minus 4. Thank you. You should, minus 4, minus 4. I can take an x out here. I'm left with an x. I can take an x out here. I can take another x and another x. And we're left with a 2 over x plus 4. I should have known that they wouldn't have. If you're not canceling anything, likely I made the mistake, right? Okay, are you guys clear? Okay, that's it for our recording today.